You know, we've all seen the headlines. AI can write code, it can fix bugs, it can even crush programming tests. It's an absolutely incredible leap forward. But here's a thought. Does just generating correct code mean an AI has, true problem-solving skill? Well, that's the real question we're going to dig into today.
It's a heck of a question, isn't it? And honestly, in some ways, the answer is, yeah, kinda. On certain standardized tests, the top AI models are already performing right up there with the best human programmers in the world. But, as it turns out, we might be asking the wrong question, or at the very least, using the wrong tests to find the answer.
And this is really the heart of the issue. The benchmarks we've been using, the ones that used to be really challenging, are now becoming too easy for these new AI models. They're hitting max scores, or saturating, as the researchers call it. And that means we're losing our ability to even tell if they're getting any smarter. We've basically created a blind spot, and we desperately need a new way to measure what truly advanced reasoning even looks like.
So to solve this, researchers are proposing a whole new framework, and it all boils down to a really simple but powerful analogy: the difference between a sprint and a marathon.
This right here breaks down the two worlds of competitive programming. See, most AI benchmarks have focused on what you could call sprints, short problems, a single right answer, you either pass or you fail. It's like a 100-meter dash. But the real world, it's almost never like that. It's much more of a marathon. These complex, open-ended problems where you don't just find an answer, you have to refine it, tweak it, improve it over weeks to get the highest possible score. It's all about strategy, endurance, and learning from your mistakes.
So how in the world do you test for marathon skills? Well, say hello to ALE Bench. This is the very first benchmark designed specifically for these long-haul, marathon-style competitions, and it's built to mirror the messy, complex problems we face out in the real world. ALE Bench is based on something called a heuristic contest. Now, these are competitions for what I can only describe as wicked hard optimization problems. The kind of problems where finding the single best solution is basically impossible. Think of it like a video game where the high score is always up for grabs. The goal isn't to be perfect, it's to be better than you were yesterday. It's all about continuous improvement.
And these aren't just some abstract puzzles either. Oh no, these are the kinds of logistical nightmares that huge industries have to deal with every single day. I mean, how do you find the absolute most efficient route for thousands of delivery packages? Or how do you schedule airline crews all across the globe? Or balance a national power grid in real time? These are the exact marathon problems that ALE Bench throws at the AI.
The way these marathons work, whether you're a human or an AI, is this constant loop. It's not a one-and-done kind of thing. You get the problem, you code up a solution, you test it, and you get feedback on your score. Then you take that feedback, you refine your code, and you try again, and again, and again, sometimes for weeks on end, before you finally submit your absolute best effort.
And this whole process, this long horizon improvement, is exactly what we see with human experts. They don't just throw their first idea out there and call it a day. Nope. Over a 2-week contest, you see their score climb steadily as they get new insights, fix little bugs, and fine-tune their strategy. It's this slow, deliberate climb to peak performance. So the big question is, can an AI do that too?
All right, so the researchers put it to the test. They took the most advanced AI models out there and pitted them against thousands of human contestants in the ultimate coding marathon, ALE Bench. And the results were, well, they were fascinating. The top AI models blew past the human novices, no problem. But, and this is a big but, they still fell pretty short of the true human experts. There's a really clear gap. The AI is good, don't get me wrong, it's very good, but it's not at that elite expert level. Not yet. I think the best way to think about the AI's performance is to imagine a brilliant but really inconsistent rookie athlete. You know the type. They can have these moments of absolute genius, these flashes of brilliance, but they just don't have the steady, reliable performance of a seasoned veteran. And the data, it backs up this analogy perfectly. Check this out. The top AI model actually hits those truly elite, top-tier scores more often than a comparable human expert. It has a higher peak, but look at that next line. The human expert consistently delivers strong scores over 56% of the time, while the AI is way down at about 32%. So the AI can hit higher, but the human is just way more reliable. It's a classic high-variance performer. As the researchers themselves put it, this shows a significant disparity between the AI's strengths and weaknesses. It can hit a home run, for sure, but it also strikes out a whole lot more often than the pros. Okay, so this leads to a really critical question. Is the AI actually demonstrating genuine, long-term reasoning here? Or is it just a brute force attack?
throwing thousands of random ideas at the wall and just getting lucky every once in a while.
To figure this out, they designed this really clever experiment. They compared two different strategies. On one side, you have the brute force search. The AI makes 150 completely independent, one-shot attempts at the problem. On the other side, you have the refinement strategy. The AI takes one single attempt and just iteratively improves it for 4 hours straight, learning from feedback the whole time.
And the results? Whoa, they are undeniable. You can just see the power of learning here. In every single case, the one attempt that was thoughtfully refined over time dramatically outperformed the very best result from 150 different brute force tries. This is not just luck. Something real is happening here.
In fact, the performance gap was massive. We're talking over 300 points on average. This is the proof. Success in these marathon problems requires the ability to learn from feedback and build on what you did before. It is genuine, long-horizon problem solving. So, what does this all mean for the future of AI development? Where do we go from here?
Well, the big takeaway is that if we want AI to tackle the truly complex problems in science, in medicine, and industry, we have to start focusing on these marathon skills. We have to move beyond these simple pass-fail tests and start building models that can show consistency, strategic thinking, and the ability to refine a solution over a really long time.
So if you're going to remember anything from this, remember this. 1. Today's AI is already at a pretty impressive intermediate human level for these super complex tasks. 2. The biggest gap between AI and human experts isn't peak brilliance, it's consistency. And finally, number 3, new benchmarks like ALE Bench are absolutely essential. They give us the right measuring stick to guide the next wave of progress in AI.
Which really leaves us with this final, fascinating question. For years, the goal was to build an AI that could code, and we're pretty much there. The next and much, much harder challenge is building an AI that can truly engineer, one that can strategize, adapt, and refine solutions to the world's toughest problems, not just for a minute, but for the entire marathon.